that is going to be led by Mr. Muhammad Andri Budiman SC, MCOM SCMEM. To Mr. Andri, time is yours. Please, Mr. Andri.
Okay. Greetings, ladies and gentlemen. Let us bow our head for a moment to pray to God Allah Subhanahu wa Ta'ala so that our international conference can be successful and beneficial to all of us. I will lead this prayer based on the teaching of Islam, and for those of you who are not Muslims, you are cordially invited to pray according to your own belief. Let us start the prayer. A'udzu billahi minasyaitonir rajim. Bismillahirrahmanirrahim. Alhamdulillahi rabbil alamin. Hamda yu'afi ni'amahu wa yukafi mazidah. Ya Rabbana lakal hamdu kama yanbaghi li jalali wajhikal karim wa azimi sultanik. Allahumma salli ala Sayyidina Muhammad wa ala ali Sayyidina Muhammad. O Allah, today we gather from around the world in a Zoom meeting to initiate the 5th International Conference on Computing and Applied Informatics 2020. Please, Allah, lead this international conference as a useful science assembly, as a medium of sharing useful ideas, knowledge, and experience of scholars, researchers, and students of various disciplines. May the conference we organize today benefit to our life, broaden our knowledge, shine our ideas, and lead us to be successful, productive persons, which in turn will boost the dignity of humanity, our nations, and the whole world. O Allah, guide and bless our hearts and our minds with the light of your guidance. Impart your supreme wisdom upon our activities. Help us to speak our minds clearly. Help us to listen to each other, respect each other, love each other, so that we could become amongst the blessed people. O Allah, show us the right path and give us knowledge and strength to perform good things and protect us from any wrongdoings and any wrong intentions. O Allah, only you who are the one who can fulfill our dua. Rabbana atina fid dunya hasanah wa fil akhirati hasanah wa qina azaban nar wa dakhilnal jannata ma'al abror ya aziz ya ghaffar ya rabbal alamin. Subhana rabbika rabbil izzati amma yasifun wa salamun alal mursalin walhamdulillahi rabbil alamin.
Thank you, Mr. Andi, for reading the prayer in these occasions. Next, ladies and gentlemen, is singing National Anthem Indonesia Raya. Continuing with our next agenda, ladies and gentlemen, I would now like to invite the General Chair of ICCAI 2020, Doctor of Engineering Ade Chandra, to deliver the welcoming speech.
The Honorable Rector and Vice Rector of Universitas Sumatera Utara, the Honorable Dean, Vice Dean, and colleagues from Computer Science and Information Technology faculty, the distinguished professor as our keynote speaker in this special event, the Honorable Committee, the guests, the participant of this event. Assalamualaikum warahmatullahi wabarakatuh. Good morning. On behalf of the organizing committee, I'm pleased to welcome you to the 5th International Conference on Computing and Applied Informatics 2020. The Faculty of Computer Science and Information Technology, Universitas Sumatera Utara, is proud to once again have the privilege to hold this event at this magnitude. As we feel together that over the past few months, the current situation requires society to change its behavior and adapt quickly. The interaction between individuals in this digital world also increasing rapidly, and modern society tends to be more dynamic. Industries and organizations are also forced to optimize their information technology in most of their business process to survive. As the result, we need to perform digital transformation to survive in this pandemic era. And in order to meet this change, the researchers are on the front line to develop innovation and drive the transformation. This transformation itself must be performed respectfully and responsibly. And every innovation will eventually come at cost. Thus, it is important to maintain a certain set of rules in performing research and applying innovation. Communication and collaboration amongst researchers are the key factor to enhance the research process while maintaining the sustainability of our environments. Hence, as one of the best higher education institutions in Indonesia, we are obligated to accommodate the need to communicate among the scientists. In today's we have 51 outstanding work from authors from 6 different countries that have been through a challenging review process. With the acceptance rate of 59%, it is unfortunate for us to see that some of high quality manuscripts didn't manage to go through the review process. Thus, allow me to give my appreciation to every author that has participated in this event, and also to congratulate to all the invited authors who have their manuscript passed the process. Next, I would like to welcome our distinguished professor as today's keynote speaker. We have Professor Hendro Wicaksono from Jacobs University, Bremen, Germany. And we have Professor Matthew Endeli from Asian Institute of Technology, Thailand. And we also have Professor Gyun Woo from Busan National University, South Korea. It is an honor for us to welcome you to our event, and thank you very much for your willingness to participate in this event. We believe that your contribution may become a valuable insight for us in the future research to perform. And lastly, I would like to give my highest gratitude to all the committee, international committee, the steering committee, and especially for the organizing committee, that it is my privilege to work alongside the current committees that have repeatedly shown an outstanding effort to make this event possible. Let me conclude by welcoming all of you to the 5th International Conference on Computing and Applied Informatics. I'm confident, I believe that this event will be an excellent opportunity for us to share our innovation and knowledge. I wish you have a rewarding exchange to this event. Thank you very much. Wassalamualaikum warahmatullahi wabarakatuh. Good morning.
Thank you, Doctor of Engineering Ade Chandra, for delivering the welcoming speech. Ladies and gentlemen, before we continue to the next agenda, allow us to present the beauty of our beloved city, which is Medan, in North Sumatra, Indonesia, because the committee already prepared a video for it. Please enjoy. Next, we are going to listen to the welcoming speech of the Dean Faculty of Computer Science and Information Technology, Universitas Sumatera Utara, Professor Dr. Opim Salim Sitompul, MSc. Ladies and gentlemen, please welcome Professor Opim.
Thank you. Assalamualaikum warahmatullahi wabarakatuh. Good morning. May God bless all of us. Our honorary guest, Rector of Universitas Sumatera Utara, in this case, Vice Rector 3 for Coordination and Research, Vice Deans of Faculty of Computer Science and Information Technology, Deans and Vice Deans of Faculties in Universitas Sumatera Utara, our honorable keynote speakers, Professor Matthew N. Daly from Asian Institute of Technology, Thailand, Professor Gyun Woo, Busan National University, South Korea, Professor Dr. Ing Hendro Wicaksono from Jacobs University, Bremen, Germany, General Chair and all steering and organizing committees of ICCAI 2020 staffs, ladies and gentlemen, participants and presenters of ICCAI 2020. First of all, our sincere gratitude will always be given to Allah, the Almighty, which has given His blessing to all of us in performing this highly respectable conference today. Salawat and salam should always be given to Muhammad Sallallahu Alaihi Wasallam, who enlightens our heart to be always in good deeds. Honorable guests, ladies and gentlemen, on behalf of the Faculty of Computer Science and Information Technology, Universitas Sumatera Utara, I would like to welcome you all to the 5th International Conference on Computing and Applied Informatics 2020. This event is one of our many efforts to establish our faculty as a reputable education institution internationally. As part of Universitas Sumatera Utara, who recently just listed in the QS World University Rankings, we are obligated to contribute to the global research effort to develop the society. Thus, we decided to hold 2 annual international conferences, IEEE sponsored conference Databia and ICCAI. I can proudly say that both of these conferences have been held well by our committees and received positive feedback from participating researchers. I would like to use this moment to introduce also our new master's program in data science and artificial intelligence. This program is one of our efforts with other education institutions to keep up with the current skill required by modern industry. This program is an international collaboration effort established by Erasmus+. Our faculty is one of the 3 selected institutions to receive this grant. We have collaborated with our other international institutions throughout Europe and Asia to develop a curriculum that fits the current trend and development. Respectful ladies and gentlemen, the seminar theme entitled Redefining Digital Transformation for Societal Well-being in Sustainable Environment is a proper theme in this pandemic era, where the positive impact of the current situations allow us to speed up digital transformation. What we need from this transformation is higher quality of life pertaining to a sustainable environment. The ICCAI 2020 conference this year is the 5th conference series of the Faculty of Computer Science and Information Technology, Universitas Sumatera Utara. In this occasion, allow me as the representative of the faculty to extend our gratitude to all our keynote speakers, presenters, and participants and a very high appreciation to the steering committees and organizing committees for their contribution in order to make this seminar successful. Welcome to the 5th ICCA 2020. Billahi taufiq wal hidayah. Wassalamualaikum warahmatullahi wabarakatuh.
Thank you, Prof. Opim, for the welcoming speech. Next, we are going to listen to the welcoming speech of Rector Universitas Sumatera Utara, which is going to be associated by the Vice Rector on Coordinations and Research of Universitas Sumatera Utara, Professor Dr. Andes Mayudin KM Nasution, MIT PhD. Ladies and gentlemen, please welcome Professor Mayudin. I'm sorry, Prof, it's still mute.
Thank you. Assalamualaikum warahmatullahi wabarakatuh. Peace be upon you, all of you, and Allah mercy and blessing. Let us express our gratitude to Allah Subhanahu wa Ta'ala, God Almighty, that we can gather today, even though we are online for a scientific activity, knowledge dissemination. Allahumma salli ala Sayyidina Muhammad, dear honorable, the keynote speakers, Professor Gan Hu from Busan National University, South Korea, Professor Matthew Ndile from Asian Institute of the Technology Thailand, and Professor Dr. in Engineering Hendro Wijaksono from Jakob University, Bremen, Germany. Thank you all. Welcome to Universitas Sumatera Utara. Dean of Faculty of Computer Science and Information Engineering, University of Universitas Sumatera Utara, and all vice dean present here. The chairman of the committee, Dr. Ade Chandra, and all the members, the committee who cannot be mentioned one by one. Thank you for all your hard works. Presenter and participants who have attended together today, welcome and join the Universitas Sumatera campus. Ladies and gentlemen, ICCAI, one reputable conference, is not only the first by Universitas Sumatera Utara and in Universitas Sumatera Utara, it also support to study programs, science, computer, and information technology, faculty, and Universitas Sumatera Utara to enter the international ranks. Therefore, this conference need to be continuously held so that Universitas Sumatera is well recognized by the world in the development of the science and knowledge. Therefore, by saying Bismillahirrahmanirrahim, I state ICCI 2020 International Conference on Computing Applied Informatics officially state is open. Good conference and good luck. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you, Professor Dr. Andes Mayudin KM Nasution, MIT PhD, for the welcoming speech and also opening the ICCAI 2020. Ladies and gentlemen, before we continue our next agenda to the keynote speech sessions presented by the first keynote speaker, I would like to inform you that there is a technical problems with the sessions currently. So meanwhile, we need to wait for the keynote speaker to be present in here. And also we prepared a video for you to enjoy. Thank you. Ladies and gentlemen, we are now ready to continue our next agenda, that is to hear the keynote speech sessions presented by the first keynote speaker, Professor Matthew Andeli from Asian Institute of Technology, Thailand. These keynote speech sessions will be moderated by Mr. Amir Sharif, SSC MCO. Without further ado, ladies and gentlemen, please welcome Mr. Amir.
Okay. Good morning, Professor Deli. Hello. My name is Amir Sharif from the University of Sumatera Utara, and I'm glad and I'm honored to be your moderator for this for our first keynote speaker event for this conference. So before we begin, please allow me to introduce some of your background, some of your extensive background to our audience here. So, Professor Matthew Andeli is currently affiliated with the Asian Institute of Technology Klong Luang AI Center in Thailand, and he has publication topics in many fields, mostly related to artificial intelligence, traffic engineering, computing, computer vision, motorcycles, road accidents, road safety, and so on. And Professor Deli received his PhD degree in computer science from University of California, San Diego, California, USA in 2002. And he joined Department of Computer Science and Information Management of the Asian Institute of Technology, Bangkok, Thailand, as an associate professor. So, Professor Deli, if you don't mind, I find your background is very interesting and somewhat has many historical common grounds with me. Yeah. First of all, if I may ask you a bit of a personal question, I hope you don't mind. Since you are, I see you received your PhD degree from the UCSD, California, and how far would you say from San Diego to Oakland, California, Professor Deli?
If I had to guess, it's yeah. I've driven that distance many times. I think it's but I don't know, maybe 300 miles, 400 miles.
So it's quite far. It's quite far, yeah. Because I happened to be born in Oakland, Prof. Deli. Wow. But way back in 1969. So when my dad was getting his PhD from Berkeley, so I was born there, but unfortunately, not long after my birth, he completed his study and was taken back to Indonesia. So I had no experience there. And another regarding your research topics, I see that you have a lot of interest in traffic and namely motorcycles. Do you ride motorcycle yourself, Prof. Deli?
No, I don't. I think it's very unsafe.
It's very unsafe because unfortunately in my spare time I do ride. I like to ride fast bikes, but I think it would be interesting to maybe to read some of your publication in this area and try to apply it to my riding habits. Okay. Okay, if you may, if you don't mind, maybe I'd like to explain a little to our audience in Indonesian about what we just spoke about. If you don't mind, sure. Please give me like a couple of minutes. Yeah, I won't take too much of your time. Oke, baik. Assalamualaikum warahmatullahi wabarakatuh. Selamat pagi semuanya. Adalah suatu kehormatan bagi saya untuk menjadi moderator pada sesi keynote speech pertama ICCAI 2020 ini. Dengan keynote speech-nya dibawakan oleh Profesor Matthew Andeli yang berafiliasi dari Asian Institute of Technology Thailand. Nah, dari latar belakang beliau ya yang memiliki publikasi banyak di bidang artificial intelligence dan juga banyak terkait dengan lalu lintas, keselamatan lalu lintas, kecelakaan dan salah satunya juga sepeda motor. Ya, kemudian juga dengan biografi beliau yang menerima PhD-nya dari University of California San Diego. Nah, ini jadi agak sedikit menarik buat saya, bukan menarik ya, jadi agak sedikit menggelitik gitu ya, karena San Diego tuh tadi saya tanya berapa jauh dari kota Oakland. Nah, katanya itu sekitar 300-400 mil, jadi masih cukup jauh. Nah, karena apa? Karena saya sendiri kelahiran dari Oakland, California gitu ya, ketika ayah saya mengambil PhD-nya dari Berkeley gitu. Cuma sayangnya tak lama setelah saya lahir, orang tua saya menyelesaikan studinya dan saya dibawa pulang ke Indonesia, jadi nggak sempat merasakan hidup di Amerika gitu. Nah, kemudian juga terkait topik penelitiannya, ya salah satunya yaitu sepeda motor. Saya bertanya kepada beliau, ya apakah beliau sendiri seorang pengendara sepeda motor? Ya, dan ternyata sayangnya tidak, karena beliau ternyata menganggap sepeda motor itu sangat tidak aman gitu ya. Ini jadi kebalikan karena saya sendiri hobi ngebut naik motor gitu ya. Oke lah. Baik, saya rasa cukup cukup beating around the bush gitu ya. So Professor Daly, I think without many further ado, I think we would all be very anxious to follow your speech on this first keynote speech session of ICCAI 2020. So, Professor Daly, I give the floor to you, if you may, please. Thank you very much.
Yeah, thank you very much, Professor Sharif. So I'm really happy to be here today. Let me try to share my screen. Okay, so can you see my screen? Oh, I think it's showing the wrong one. Just a moment, sorry. Oh, you can see my screen, right? Sorry, could someone confirm whether they can see my screen or not? Just
yes,
want to make sure.
It's already on, Professor Daly. I think you may proceed.
Okay, great. Yeah, so anyway, I'm very happy to be here today to talk to all of you and get to hear more about your research. So what I want to talk about today is getting something for nothing. So I think everybody likes to get something for nothing. In this case, we're going to see how to accomplish this feat using generative adversarial networks, or GANs. Okay. So I think everybody knows this story, that today we're living in the age of deep learning, right? Deep learning methods are now solving all kinds of difficult problems, from image recognition, natural language understanding, chatbots, all kinds of problems. We know that the last classical AI game playing problem, which was Go, was actually was in some sense conquered by deep learning, in particular deep reinforcement learning, back in 2017. And this was much sooner than anybody anticipated prior to the emergence of deep reinforcement learning. And so the field is moving really, really fast, and it's actually quite difficult to keep up with what's going on in the area of deep learning. But anyway, if we can, then we'll have some great opportunities, right? Because deep learning models are improving performance in just about every type of intelligent system that you can imagine. So all of this recent effort in the last 10 years culminated last year in the award of the Turing Award to some of the three scientists that had the most impact in the area of deep learning. So LeCun, Hinton, and Bengio. So anyway, so this is the situation where we sit today, that deep learning is dominating just about every field of intelligent systems. Okay, so the problem comes up, though, when we actually don't have enough data in order to perform the task that we're trying to perform. So is there anything that you can do if you are data poor and not data rich? Okay, so that's the problem that I'll start to talk about today. Let me take a simple example. Suppose that you would like to detect changes in images. Now, this is just an example of one possible application. It's not the only application that is amenable to the kinds of techniques that I'm going to talk about today. But you can see the idea of this problem, right? We've got, in this case, a satellite image taken before and after some changes have occurred. And then it's the responsibility of our intelligent system to try to detect the changes that have occurred in between the two images, and then perform some further classification of those changes that have occurred. For example, to note that some rooms have been added to a building structure, or that the roof is deteriorating, etc. Right. So there are a lot of applications for these kinds of change detection models. Okay. So let me talk more specifically then about one particular type of change detection, which is vehicle change detection. Okay. So the idea here is that you've got two images of a vehicle taken possibly before and after some change has occurred, and then you would like to identify any possible changes to that vehicle. As you can see from the images that I'm showing right now, this is actually a quite difficult problem. Even if you constrain yourself to take the picture from the same perspective or point of view, then there are all kinds of differences that might come up. For example, shadows, reflection, shading, just every imaginable kind of difference might lead an intelligent system, a so-called intelligent system, to think that there are changes between these two images, when in fact those changes are just due to the background or due to illumination and so on. Okay, so this is a difficult problem. It's an interesting problem because it's challenging, but it's also extremely useful. And you can imagine various applications in areas such as in the area of auto insurance, right? So an insurer would like to verify that your vehicle is undamaged before they offer you insurance. And then when your vehicle is damaged, they would like to pay you, right, for the damage to your vehicle, if necessary, according to the real change that has occurred, right? Not some false change that you claim has been made. Or in the case of the automobile repair shop, right? They want to verify that the insurance company is being charged for legitimate repairs to a vehicle. Okay. Another application would be car sharing. So suppose we rent out a vehicle to people just by leaving it on the side of the road and allowing people to borrow the car and drive it around. Well, when someone is finished with your car, you would like to verify that the car is intact, right? There's no damage done to the car. And of course, if someone has crashed your car, you'd like to get compensation for that, right? So so if we could perform this task automatically, let's say just having the driver of the car take a few pictures like this of the vehicle, and then submit, say using their mobile camera or a mobile application, and then submit them to your cloud-based vehicle change detection service, then you could automatically assess any change or damage to the vehicle. Okay. So this is an interesting problem, and also an economically significant problem for a lot of different reasons. Right? Not only for vehicles, but other applications as well. Okay, so in order to accomplish this kind of task, this is what we need to do. So the input to the system is going to be two images of the same vehicle that are taken from approximately the same viewpoint. Okay. That's the assumption. Of course, the background could be different. The illumination could be different. Reflections and shadows could be different. Time of day could be different. All these things could be different. So then what do we have to do? We have to take the before and after image. We have to isolate the vehicle in each of these images. We have to align the two images pixel by pixel. Then we have to classify each of the pixels in the image as being changed or unchanged. And once we complete that, then we'd like to perform some further classification of the change or damage. Okay, so let me talk about how we approach this problem at AIT, at the AIT-AI Center. We had some clients that are interested in this kind of application, both in the car rental space and in the automobile insurance space. So we thought we would try to build a service that would satisfy the needs of these particular customers. Okay, so what we did is we undertook the task of first just creating a data set that could be used for this kind of problem. And we don't have we don't have pictures of cars before and after damage, right? Or not many of those, at least. We can get some from the internet, but it's quite difficult to obtain that kind of image. So what we started with, we thought we'd get just different images of the same vehicle from different points of view, and assume that these vehicles are unchanged, right? At least to be able to build sort of the first half of the model, right? Which is your model would have to classify as unchanged any vehicle that is indeed unchanged, right, before and after. So we set up some cameras at the entrance to our institute at AIT, and you can see the diagram here. We set up 8 cameras in order to get 4 pictures of each vehicle coming in and leaving the campus from 4 different perspectives. Okay, and so we do this automatically, and then we also perform license plate recognition so that we can then associate images of the same vehicle when they enter the campus and when they leave the campus together automatically, so we don't have to perform too much work in order to construct this data set. But we started out collecting 500 pairs of images of cars entering the campus and leaving the campus in this way, using the 8 cameras that we installed plus LPR. Okay, so step 1, so that was step 0. Step 1 then is just trying to isolate the vehicle so you can process the information about the vehicle in the image. So this task, it turns out, is already solved. We didn't have to do anything. There's a model called Mask RCNN that is from 2017 that is excellent at performing this task, which is called instance segmentation. Instance segmentation means isolating the pixels belonging to a particular object and separating the different objects in the scene if there are multiple ones. So as you can see here, Mask RCNN, without any modification by us, does pretty well at separating the vehicle from the background. So step 1 is basically solved. Okay, so now the next problem is step 2, which is image alignment. Okay, and here's where the problems start to arise. So if you think about image alignment, what it means is that for every pixel in a first image, you want to find the corresponding pixel in the second image. Okay, and the relationship between these 2 images is definitely nonlinear, right? It's not a simple linear warping or anything like that, right? Because we have a 3-dimensional object that has been possibly rotated and so on. So this is a pretty difficult task. If you wanted to build a deep learning model to perform this task, you could do it. But what would you have to do? You would have to provide thousands and thousands of examples of an input pair of images and then the corresponding aligned image. Okay, so I don't know if anyone has ever tried to do this. I guess this kind of very detailed annotation of correspondences between 2 images is the kind of things that Hollywood movie producers do, right? When they want to, say, overlay one video or a special effect on top of a character in a movie. Yeah, it's not easy to do this, and to do this for thousands and thousands of images is going to be quite expensive, right? So even the richest person on earth probably would not want to pay somebody to find manual correspondences between pairs of images of vehicles, right? So we want to try to do something different. Okay, so now I'd like to introduce, so I think some of you may be familiar with GANs already, but for those of you that are not familiar with GANs, I would strongly encourage you to become familiar, because the GAN is probably the most important invention in machine learning in the last 10 years, right? So the GAN stands for Generative Adversarial Network. They're due to Ian Goodfellow back in 2014. Some of you may know Goodfellow as the author of the major deep learning textbook from MIT Press, right? So a GAN consists of 2 neural networks, G and D. Okay, G is a generator. The generator takes as input some kind of representation of some input plus some noise. Okay, and it's tasked with outputting a sample that is as similar as possible to samples taken from a real data distribution. Okay. At the same time, the discriminator, D, is a neural network that is tasked with trying to tell the difference between real samples from a real data distribution and fake samples that are created by the generator. Okay, so during training of these kind of neural networks, they play this kind of minimax game, right? Where the discriminator is trying to maximize its classification accuracy as to whether its inputs are real or fake, and the generator is trying to minimize the discriminator's classification accuracy, basically trying to fool the discriminator as much as possible. Okay, so this is a pretty actually, maybe when you first hear about the GAN, you may not think much of it, right? All you're doing is modeling some data distribution, right? So what good is that? Well, the good thing the good thing about a GAN is that once you train this generator, then you can just pull the generator out, throw the discriminator away, and then you can use this generator for a variety of different tasks. Okay. All right. Turns out that these GANs and various variations on the theme are extremely versatile. They can be used in a lot of different contexts and with a lot of different ways that they can be used. I'd like to show you one example, which is called the cycle GAN. This is a really, truly incredible achievement in machine learning. These cycle GANs are able to do things like transfer Monet paintings into photographs, right? Or vice versa, take a photograph of an arbitrary scene and then render that scene in the same style as if Monet painted a painting of that particular scene. The cycle GANs have been trained to convert zebras into horses and horses into zebras automatically, right? Without this is purely unsupervised learning, right? There's no supervision of exactly how to perform the task. We can change image styles between summer and winter and summer, photograph to various art forms, and so on. Okay, so this is a truly amazing achievement back in 2017. These so-called cycle GANs. So really interesting results here. Okay, so what we did was we looked at this cycle GAN from 2017 and said, what if we can use this to help to solve the problem that we just talked about, that Jeff Bezos doesn't want to pay somebody to annotate images at a very detailed level necessary to align to images of a vehicle or anything that you would like to align. So for this, we designed a new GAN. We call it the image alignment cycle GAN. Okay, so it's a little bit more complicated than the basic GAN or the cycle GAN that you just saw. But not by much. Okay, so here's the basic idea. So we have two copies of the same generator, G1 and G2, and then we have just a single discriminator, D. Okay, and it works like this. So what G1 does is it takes two images of the same object rendered at different times and from different perspectives and with different backgrounds. Okay, and then its job is to try to align X2 with X1. Okay, so that means what it has to do is it has to calculate a flow field that says for every pixel in the image X2, what's the corresponding pixel in X1 for every pixel. Okay, then what the generator does based on that flow field is it then performs the warping. So it warps the pixels of X2 into correspondence with the pixels in X1. Okay, so we treat that result, which is X2 prime in the diagram, we treat that result as a fake image, right, and show that image to the discriminator. Okay, the discriminator is tasked with telling the difference between samples created by the generator, right, X2 prime, and actual real samples of the same vehicles, right, which are not aligned, the X1. Okay, so the discriminator is trying to maximize its accuracy in classifying the task. G1 is trying to minimize D's accuracy in classifying the images as real or fake. Okay. Now, yeah. So anyway, in order to do this, so in order to perform this accurately, right, to actually trick D, I hope you can see that what G1 needs to do is it needs to warp X2 onto X1 in a way that is as realistic as possible, so that the resulting output image looks as good as possible. Okay. So that's the basic idea. There's a little bit more here. Okay, so I just described the discriminator loss, which means that the discriminator is going to be trained to maximize its classification accuracy, whereas the generator is going to be trained to minimize the discriminator's classification accuracy. There are two more, in fact, loss functions that we need to worry about. One is called the cycle loss, and the other is called the correspondence loss. Okay, so the cycle loss says that when G2, which is actually just G1 flipped around, when G2 takes a fake image, x2 prime and x2, and then warps them onto each other, then the result should look as similar as possible to the original x1. Okay, so we take x1 and x2, we produce x2 prime, we pair x2 prime with x2 again, we put them through the generator again, and then the result should be, basically we're saying that when we warp one image onto another, and then we warp that result onto the second image, then the result should be as similar as possible to the original image. Okay, so that's the cycle loss. And then the last thing that we need to impose here is that the fake image, the output of G1, should be structurally similar to X1, right? So that says that the flow field calculated by G1 should be as accurate as possible, right? So that we get good alignment between the warped image and the original X1, okay? So it turns out that this actually works. It might seem surprising, right? Because it's kind of like magic, right? What we did is we took an existing optical flow network called Light Flow Net, right? And we made that be the first half of G1. The second half of G1 just takes that optical flow field and then applies it to X2 in order to perform the alignment of X2 and X1, okay? Yeah, so there are many details here that you'll find in our paper once it's published. But the basic idea is that through training this model with these three loss functions, then we can achieve very good performance at the alignment problem. So this is the result. We call this the image alignment cycle GAN. Okay, and what we're showing here in the figure are four examples of vehicles where the top two vehicles are the original X1 and X2, and at the bottom is X2 warped onto X1. So you should see that in every case, the bottom of the three images is a pretty realistic looking vehicle that is in as perfect alignment as possible with the top image. So we've taken the pixels of the second image and then warped them into alignment with the first image, right? And you should be able to see that this works fairly well. And the beautiful thing about it is that we've done this in a completely unsupervised way. There's no labeling of the exact positions of the optical flows between these different cars. The model learns it itself, right? So we hope that our sponsor is going to be happy that this is relatively cheap to build this model without a lot of supervised correspondence data. Okay. So then we move on to step 3, which is change detection. So what is change detection all about? So in change detection, what we want to do is we want to take two images that are already aligned, and then we would like to find the pixels that are different between the two aligned images. Okay. So we actually tried a lot of different models from the literature. Right. There are a bunch of models out there for performing this task, and they're mostly in the area of satellite image-based change detection. Okay, so one we found that works pretty well is called STA-NET. Okay, this model is for, again, satellite change detection, and just came out this year, 2020. We found that although it performs well on its type of data, which are satellite images, still it needs fine-tuning in order to work with vehicles or with cars. Okay. So that's the goal, is we would like to fine-tune this STA-NET in order to make it perform well on vehicles and then detect vehicles. Well, so if you think about it for a minute, then you'll see that we're back to the same problem as we were before, right? We would like to train this deep learning model, and what we need in this case is we need lots of examples of vehicles with and without changes, right? And then we need to give the model the signal that, okay, this pixel has changed, this pixel has not changed, this pixel has changed, this pixel has not changed between these two images. Well, so I think our sponsor is going to be unhappy again, right? And this time the problem is even worse. it turns out that okay, annotation is one thing, right? You could have a human annotator look at these image pairs and manually decide which pixels have actually changed, right? But what's even worse than the problem of having humans annotate the images is just getting the appropriate image pairs in the first place, right? We need to find examples where we have vehicles that have changed, right, in order to get good coverage of this problem. Okay, so we need vehicles before and after some kind of change, especially an accident or maybe paint being thrown on the vehicle or something like that. So now this is going to be not only expensive but maybe impossible, right, to get thousands of images examples like that, because I don't think you're going to find 1,000 people that are willing to let you take a picture of their car and then crash it or perform some other kind of damage experiment, right? So again, we're faced with this problem that we would like to train a deep learning model. We've got a deep learning model that works very well at change detection, is able to ignore things like clouds and different lighting that occurs at different times of day and satellite imagery and find the real changes. However, it needs lots of data for training, examples of changes and non-changes. So how can we do that? Well, we're going to come back to the idea of GANs again. Okay, so it turns out that in this case, we don't really have to invent a new model for this, because people have had this idea of damage detection in a lot of different areas. In the case of the one that we found that works best happens to be called the multi-stage GAN for fabric defect detection. Okay, so this is for fabric inspection. Let's say you have a factory where you're producing some fabric and you'd like to have an automated inspection process, right, where you take a picture of the fabric and then you detect any damage or defect in the fabric that has been produced by your factory. So this is another model that came out just this year in 2020. And so the idea then is that we're going to use the same techniques that are used for damage detection in fabric to try to detect damage on vehicles, right? Now, this has never been done before, as far as we know. But the basic idea is that you treat the undamaged vehicle as sort of like the undamaged fabric, right, texture, right? Then you'd like to overlay some damage on top of that undamaged vehicle, okay? But the problem is that if you add an image patch with a scratch or a dent or something like that, then the image patch that you're laying on top of the image is not going to match up with the background that you're trying to overlay the damage on. So the same problem comes up with fabric damage, okay? And so Liu et al. Have solved this problem by using a really nice two-stage process that looks like this, okay? So the idea is first we take just a normal damage patch from a damaged car. It could be any vehicle, not the same vehicle. Just maybe you find an example of a damaged vehicle on Google, okay? Then you overlay that damage patch on top of the undamaged vehicle, okay? And then they have another model, a second stage model, that tries to fuse that damage patch with the surrounding texture, okay? In this case, the rest of the paint on the vehicle, okay? So if you look closely at these images, you should see in the first and third column, you see an image, right, with a damage patch kind of arbitrarily laid on top of the image, okay? And then in the second and fourth column, you should see the corresponding image where the Liu's fusion model has been applied to the damage patch in order to try to smooth it out and integrate it with the background. Okay, so you see a few examples here, and they work to greater or lesser degree of accuracy, right? Some of the fusion results are quite good, and some of them are not quite as good, right? So if the fusion is not good, then it would be too easy for your change detection model to detect the changes, and so it wouldn't be solving the real problem very well. But in any case, this is the technique that we're currently working with. Okay, so once that's done, then your StanNet can then pretty accurately detect the changes that have occurred between the two images. And so you see here, what we've done is we've fine-tuned STANET on examples of undamaged and damaged vehicles where the damage is now being generated by these GANs. Okay, so now you can see that we haven't quite gotten the fusion of the damage patches perfect yet. We're still working on that part, but we do see that with the ones that we have today, that as you can see here, that the change detection model is working quite well. Okay, so that's the work in progress that we're currently experimenting with these models. Okay, so what I'd like to say is this is just one example of the power of generative adversarial networks to help to actually fill in gaps in data sets where you need a large data set in order to perform some complex intelligent behavior, but you don't have exactly the image set or data set or whatever is the type of data that you require for the task. Okay, well, what the story of GANs shows and all the variations on GANs, what we can see is that if we take a little bit of a creative approach, we may be able to generate the type of data that we need in order to fill this gap without spending lots of money and time on generating and annotating manually a huge data set. So these GANs are a really flexible and powerful technique for building models that normally require large, intensive amounts without actually having to do all that work to establish those very large data sets, right? So it means, in some sense, that any of us can be Google, right? We can acquire huge data sets that we need in order to train our sophisticated models to perform complex tasks, right? If we make some creative use of these unsupervised data generation models like GANs. Okay, so that's my talk. So I just want to encourage everybody to look at what's happening in machine learning today and how we can use modern methods to perform machine learning cheaply and robustly without having to manually create tons and tons of data. And at the same time, I'd also like to put in a small advertisement for my center. This is the Artificial Intelligence Center at AIT. So we're looking for engineers and web programmers to build the kinds of applications that use the techniques that I just described today. So I'd be very happy if anybody is interested and to contact me about this work. Also, by the way, AIT is recruiting a faculty member in the area of data science and artificial intelligence. So if you know a really great researcher and teacher in this area, I'd encourage you to have them contact me. So thank you very much. So that's my talk, and so I'd be happy to take any questions that you might have.
Okay, thank you, Professor Deli, for that very interesting topic you just presented to us. It's just well, maybe you can, if I may put it in one word, it's mind blowing. Maybe, yeah. It's like many of the advances in the field of artificial intelligence today is quite mind blowing here, particularly where, like you said in the beginning, it's getting something for nothing. If this goes on, you can make the expression quid pro quo obsolete, perhaps, Prof. Deli. Yeah. Okay, so if I may try to somewhat summarize what you just presented in your speech, it's like when we face the difficulty, the difficulty of having in this case, a pair of image required for training our system. The data pairs required may be created somewhat from using like already present images, but then overlaying, combining them with what we have, and then from the result we use that as the the data set, the pair of data sets which was unavailable before is something like that. I suppose, perhaps. Am I correct? I'm just hearing this, but it's what I hope I don't make too much out of too much deviation from the paper, but it's what somewhat I tried what I gathered from your speech. It's very interesting, filling the gaps, like you said. In this case, the gaps for training data, because usually in this field, we look for available data sets for training. But in this case, you somewhat create the data sets you require using already available from other fields data, and then somewhat modifying them or fusing or overlaying them with what you have to create the kind of data sets that you need to train your system. It's very, very fascinating. Okay, so maybe we can have our first question and answer session. I think in this first session, I will accept 3 questions directed to Prof. Daly. I will take notes of your questions first. And prior to asking your questions, please identify yourself and then state your questions. If you have difficulty in stating in English, you may state it in Indonesian, and I will try to my best translate your question into English so that Prof. Daly may understand the question and give his best answer. Okay, so for this first session, I'll take 3 questions first, and don't forget to introduce yourself before asking the question. Okay. Okay, first already we have from Mrs. Erna Budiarti Nababan from our chat. Yeah. Okay, I think Prof. We'll take this as our first question. Yeah, and Mrs. Erna, I hope you will please have some patience, perhaps, before we Prof. Daly can may answer the question. Yeah, so we'll take a couple more questions, and then I will forward them to Prof. Daly, all 3 questions for him to answer. Okay, if there are any other questions, oh, okay, the second one is from Mr. Jos Timanta. Submit all the Jeff Bezos speeches. Okay, Pak Jos, I hope you don't have any personal beef with Jeff Bezos, or perhaps you have some experience with the cloud, with the AWS cloud before, from somewhat past experience, perhaps. Okay, another question, please, from another one more before we have Prof. Daly answering the questions, if you please. Okay, we already have 2 questions from Mrs. Erna Budiarti and from Mr. Jos Timanta. One more questions? Anyone? Okay, maybe.
Actually, can I ask some questions too?
Okay, who is this, please?
I'm Adin.
Oh, okay, Adin. Yes, please, Adin.
Okay, good morning. I'm Adin from final year student from Faculty of Computer Science and Information Technology. And I want to ask about the John. You said that it's unsupervised learning, right? So I just wonder how about the accuracy to test to evaluate the accuracy of, like, what kind of method that you could use to evaluate it? Because what I know is that when you use unsupervised learning, you could evaluate. You have to evaluate the accuracy using some methods, like, for instance, like metrics or that kind of thing. So I just wonder if there is the method for evaluate the accuracy of that. Thank you.
Okay, thank you, Adin, for the question. If I may summarize it somewhat, since the approach is using unsupervised learning, you would like to know what kind of methods that can be used to determine the accuracy. Yeah. Okay. Maybe I think I summarized it correctly lah. I hope gitu ya. Okay. So Prof. Daly, I think for the first 2 questions, I think you can also see those in the chat. This is one of the advantages for having a webinar session. Yeah. Anything written is it is the job of the moderator at least, because the speaker can see the question directly. Okay, Prof. Deli, I give the floor for you to answer these first three questions first. Okay, if you may, Prof. Deli, thank you.
Thank you very much. Yeah. So, so to answer Erna's question first, so the question is about the input to the discriminator in this image alignment GAN. So, so you ask, why is it x1 and x2 prime rather than comparing to x2 as the original image? So I should clarify. Maybe it wasn't clear in the slides that I presented. But in this case, what we have is so x1 and we have x2 are input to the generator. Okay. And what the generator in this case does is it computes a flow field for image for x2 onto x1. So the idea is that we then take that flow field, we apply it to x2 to create an image that is quite similar to x1. Okay. So then what that means is then we would like the discriminator to be able to to have trouble to tell the difference between x1 and the image x2 warped onto x1. So we want the warped image to fool the discriminator, right? So that's why the input to the discriminator is x1 and x2 prime. Okay. All right. If I may move to the next question.
Matt, sorry.
Yeah, go ahead.
What about the x1 prime?
Yeah, so then that's part of the cycle, right? So in a cycle GAN, so you always have you always have some case where you transform an image from one distribution to another distribution.
Yeah.
Then you need to take that result and then transform it back to the original. And so the idea is always that when you take your data through these two different domains, then the result should be pretty close, as close as possible to the original point, right? So in this case, then we want an image that can actually be compared to x1 directly using some direct similarity measure. So if we can take the warped image generated by G1, and then we can warp that onto and then we can warp x1 onto that. Then then we can warp that onto x1. Then the result should look as close as possible to the original x1. So that's the idea of two things: the discriminator, which we're trying to fool, and the cycle, which we're trying to maintain consistency of this mapping from one domain to another.
Okay, thank you, Matt.
Okay, yeah, thank you. Okay, then I'll move to the next one. Is this, do you pronounce your name Jos or
Jos? Jos. It's
okay.
Pronounced Jos. Properly, yes.
Okay, very good. Yeah, so the question was, is there any test for other damage like paint-based damage and things like that? And yes, the answer is yes. So actually, the first thing that we did before we started trying to use GANs to generate the damage images here was we actually partnered with an automobile repair shop, right? And the gentleman who runs the shop was very nice. He agreed to take pictures for us before and after he repaired the cars that were coming through his shop. And we went through this for about a month, right? And then after a month, we really only had just a very few images that we could actually use, right? So it's unfortunate. I mean, it was nice that the guy, the owner, is very cooperative, right? But it's just not the throughput is not sufficient, right?
It's not sufficient, yes.
Yeah. So anyway, yeah, actually it turns out that most repairs that go to automobile repair shops, at least in Thailand, for purposes of insurance repayment, they're almost always just like very tiny scratches to the paint on the vehicle. So yeah, so we are including a lot of those. So we take examples of those, but then we think that we have to use the style transfer method to paste those kinds of scratches and other kinds of defects onto the vehicles. So finally, I guess then this will lead into the next question, which is about evaluating the results. So maybe I'll talk about that more when I answer Amir Sharif's question. And then to answer Jeff Bezos, right? Well, No particular reason except that I was thinking about how expensive all this was and how they say that rich people don't get rich by spending their money foolishly, right? They get rich by conserving their money as much as possible. So even Jeff Bezos has enough money to buy the data set for this kind of problem, but he probably wouldn't want to, right? That's all I was trying to say. So yeah, so I don't have any. Well, I mean, other than he's the gentleman is kind of obscenely rich, right? I don't know if human beings should be allowed to be that rich or not. We don't have to get into politics here, I think. Okay, so then, if I may, I'll move on to question number 3. So the question is about unsupervised learning and how to evaluate the accuracy of the result. So yeah, this is interesting. I guess I should say that the methods are unsupervised in the sense that that no human labels need to be given to the system. But in some cases, for example, in the change detection model, it actually is doing supervised learning, right? But the point is that the labels or the targets are actually generated by a system, right? So you can just have random, you can generate generate damage patches and lay them over images randomly, and then you know where you overlaid the damage, so you know what is the ground truth for the damage for that case. So in some cases, actually under the hood, even though the human is not providing the labels, the system is providing the labels, and so then we can use an ordinary supervised learning metric. For example, in change detection, you'd like to know that there are a lot of different and recall for the change, the change pixels, and then there's also IOU, that's intersection over union for the region of measuring the accuracy of the region of the change. So there are a variety of different traditional supervised learning metrics that we can use in those cases. However, in the first one that I showed, the image alignment GAN, there's actually there's no supervision at all in that case, and we don't actually have the ground truth correspondences between the images. So in this case, the way or what we feel is the best way to evaluate the result is to find some measure of similarity between the image that the original image that we're warping to, and the result of warping the second image, right? So I showed you those 3 images, right? There's image 1, image 2, and then there's image 2 warped into correspondence with image 1. So what we need a measure of similarity between the warped image and image 1. And there are a variety of different measures that people use for that kind of thing. You could use things like use the average cross correlation, local cross correlation between the sets of images. But what people tend to use more often, there are at least two. One is called structural similarity, or SSIM. So it's a type of local contrast and correlation fit. And another one is called perceptual distance. So perceptual distance, the idea is that you perform some processing to the 2 images and get some intermediate representation of the 2 images, and then compare those 2 images to see how those 2 intermediate representations to see how similar they are. And so perceptual distance, the way it's typically done is you take a CNN that's trained on ImageNet or some other large data set, and then you run that image through the first few layers of that CNN. And then you just take the feature map representation at that intermediate level of the CNN as a representation of that's what they call the perceptual view of that image. It's kind of like, the idea is that it's be kind of like the pattern of activation across some of the neurons in your visual cortex or something like that, right? So then you compare that representation, and so that tends to work very well. In our case, we found that using, well, we use structural similarity to evaluate the results, and then we found that the model that we proposed works much better than any of the supervised learning models for optical flow that we could find. So anyway, so that's the story for how to evaluate things. I think probably the the appropriate metric is going to be different for every type of unsupervised learning problem that you're facing, right? They're quite, I think they're quite application specific. So so that would be one thing to be wary of. Try to find the evaluation measure that's good for your application. Okay.
Okay. Thank you, Prof. Deli, for the answer. I believe all of us here has still like a million questions to ask you, but unfortunately, time is not our friend here, and our time is unfortunately is up. So on behalf of all the participants and the audience of the 2020 ICCAI, I would like to give you our warmest gratitude for your time and for your sharing of your present state of research, which is, like I said before, it's mind-blowing, simply mind-blowing. Yeah. So, okay, thank you once again for this opportunity, Prof. Deli, and I think we can all, even though virtually, give a big round of applause for Prof. Matthew Deli.
Thank you very much, Matt.
Thank you very much.
Thank you, Prof. Deli. Okay, so yeah.
Thank you, Matthew, Mr.
Yeah, since my time is up, I will return the floor to our MC, Adin. Okay, if you please, Adin, the floor is yours.
Thank you, Professor Matthew and Mr. Amir. Okay. Thank you, Professor Matthew and Mr. Amir, for the first keynote speech sessions. I'm sorry there's a technical problem earlier. And once again, thank you, Prof. Matthew, for joining us as the keynote speaker for today. It is really mind-blowing, like Mr. Amir said. The next, ladies and gentlemen, the second keynote speech sessions presented by the second keynote speaker, Professor Gyun Woo from Busan National University, South Korea. And it will be moderated by Mr. Muhammad Andri Budiman, STMCom, STMM. So without further ado, ladies and gentlemen, please welcome Mr. Andri.
Thank you for introducing me. Can you hear me? Okay. So my presentation is about how to activate the students in this COVID pandemic. So it is my honor to take a keynote speaker. So I'd like to share my PowerPoint slide with a few materials, some video materials. Okay, so the title is How to Promote Student Activities in COVID Pandemic. Since I was leading just 3 classes in this semester, and in the past semester I proceeded online lectures, but it was very tricky at first time because I have to make video lectures, and so, as you know, the online lectures is not comfortable for me, and that is also true for students because students need some analog activities, but they have to transfer to the digital online digital material, so digital media. So here I'd like to show my past experience how to promote the student activities with some of the technologies and tools used here. So as you know, the life is changing now. So the COVID pandemic is started since late 2019. So it began to spread all over the world, and currently we have we have yes, yes, we have still have the problem because it is still ongoing to have 63 million cases in all of the world. So you may ask that what should we do now? So we have to participate social distancing, to wear face masks, such like this statue here, and to wash hands to protect our health. And unfortunately, our freedom can be restricted to promote public health. So that is very tiresome to wear face masks. So I'm currently in my office, but I have to wear face masks if I go outside from this office. So the same is true for the students. So students should participate in their laboratory room with face masks, and they have to wash their hands before for every outdoor activities. So the impact in education is that we have to change it to the online lectures. So in the Busan National University, most of the lectures have been transferred online. So we have two types of online lectures. One is video lecture, just recording the video, and the students just taking it by playing it. But they still need some online lectures like in this format because they have to ask some questions and they have to be assisted for solving the problems at hand. So the teachers and professors should make online lecture materials. So it is very hard for me to learn how to record and how to edit those materials. And students should attend online at a specific time if it is held online like this. And one of the most important one is the quality concern, because students can easily skip the important materials because they have no idea in the video lectures. So and some of the important concepts can be skipped also. And the teachers can easily get tired to make online lecture materials because they have to prepare more to get to read an online lectures. And most of all, student activities are highly restricted and unsatisfactory. That is really a problem in the past lecture. So as I described it before, the types of lectures are mostly in two types, and they can be intermixed. So one is video and the other is online. So in my case, I have two classes in a week, and one of them is taken video and one of them is taken online. So video is good for practicing important materials since every student can manage their pace, and some of the important portions may be taken repeatedly. So that is very good for video lectures. But online is the good points of the online lecture is that they can promote student activities. So I'd like to focus on the second one today. But the barriers of this for the student activities is that students do not want to show their faces. As you know, that the participants is just taking the pictures and it as their faces, but they are too timid, and some of the girl students do not show their faces because they are not good style, and they need some makeup for them. And the one-to-one communication, another barrier is that one-to-one communications of the professor and students and among the students is highly restricted. That is more problems of the barrier of student activities. So basically, how to overcome them? We cannot do that completely. We cannot overcome that completely because it is still restricted. But we have to understand their concern. Some students are not prepared to dive into online. So some students is just taking some other activities and just like running on the treadmill and taking the lectures with their headphones only. And others may prefer to participate anonymously. They do not want to show their names, but they want to ask me questions in a private manner. So we need some appropriate tools to facilitate the communications among the students and between the professor and the students. As you know, the online conference tools, Zoom is a good tool. So we are taking Zoom, and there's another conferencing tools, GoToMeeting, Microsoft Teams, etc. And in Busan National University, we are taking Zoom as the main tool for online conferencing tool, online lectures. And video recording tools are free. Some free video recording tools include OBS Studio and Loom. This is taken from the as a plugin in your website. But these tools is not so enough for the full communication. So I'd like to paraphrase the problem as in the graph theoretic point of view. For example, the video lecture is just transferring the material in unidirectional, and this feedback of students, if this is a teacher and this is a student, this feedback of the students may be delayed in a video lecture, and they don't like to show them, so they prefer anonymous feedback. And another problem is that if we are taking the online lecture, then you have multiple of students, but mostly the online lectures in unidirectional. So the students is taking the lecture, but we have no idea whether they are really taking the lectures or not. So in any case, students can hide them on the back side of the lecturer, of the teacher. So that is really a problem. So the student types can be categorized into two types: active student and passive students. So active students can participate easily using existing tools. So here I can take some chatting section, and some of the students is asking questions while I'm not lecturing. So this can be performed easily, and they eagerly show their needs using chatting and voice. Even private messengers, they want to chatting and they want to participate, and even they want to draw some figures in my lecture board. In some cases, they prefer an additional channel to participate. But the passive students are really is getting in trouble for teachers. It is extremely hard to make them move. So they prefer private chatting rather than public, and they prefer anonymous feedback rather than public. So how can I facilitate those passive students? That is the main concern of my lecture. So one way is to promote teamwork. So the communication among students can be facilitated by teamwork. So you should think about the communications between the students. So rather than the direct blue arrows here, you should add these red arrows in a group. So that can be possible in Zoom. So you know that there is a meeting room in Zoom, and that can be fertilized to the teamwork. But I'd like to show you a simple hint how to do it in a fast manner. And then output material should be collected as a report or some of the result. But writing a report is another burden for students. So they want to share their ideas using online board. So so we have two tools. One is the meeting room. The other is the online board. And the online board should be shared for the students or for the teams or all for in the classroom. So the first problem for the organizing the meeting room can be fertilized by multiple meeting rooms. So the names of the meeting room are automatically generated, but the simple tip for managing the members is that guide the students to change their names. So by prepending the team number. For example, my name is currently Gyun-woo, but you know that I can change it here with my local menu. Then I can change it. Oh, sorry. So it was reversed with the arrow. Sorry. So I can change it with my name 01. If my team number is 1, then you know that my name is changed here with 01 Gyun-woo. And some of the members of the same team may change their name to much like the Matthew. Matthew maybe change it 01 Matthew. Then you know that if you'd like to assign the meeting room for the members, then they are sorted for the team numbers. So it is quite convenient if you have to handle multiple members. So using this simple trick, it is much helpful for simplifying the assignment the members of the meeting room. And second one is a Jamboard. You know that if you have a Google account, you can open a Jamboard. Okay, so it is just created if once you have a Google account. So if you visit the jamboard.google.com, then you can create your board, and that board can be shared. So let me show this. I just created this Jamboard this morning. So if you click this, then you can take a Jamboard like this. So I want to share this with you with a link. So the links may be copied to the chatting section. So I share this. Then you can click this Jamboard, and it is in public. So you can take any kind of note here. So I'll show you. I'll show you with this Jamboard. So you can make another sticker. This is my idea to promote the accuracy of cycle gang. Okay, then you can write this. Okay, so can you see this? So you can select any kind of activities. So please write anything if you have some other ideas how to activate the passive students in online environment. So this is one way to share the ideas. But for passive students, they want to show their idea anonymously. Okay, so this is very good. So I just seen some of you is participated to this link, but the names of them is just switch it to um, to a maiden name, such as a panda is participated to this board, or an old fox is participated to here. So it is provided by the system. So it is a very good experience for me to share the ideas with passive students. Okay, so just don't hesitate to write something on this board. So you can make it using your publish using your ideas anonymously. Another one is Padlet. Padlet is very similar to the Jamboard, and it require, but it is more wonderful that you can change the background, and you can take the QR code here. So if you have a smart device, you can just take a picture of this QR code and you can jump into this link. So I'd like to switch the share the link again. In the chatting section. So you can just press it and then you can participate to write your ideas in your Padlet. So let me just open this Padlet.
Padlet mana ini?
Yes, it is much like the Jamboard, but you know that the background is changed to this conference, and you can add anything. Okay, so with just clicking the plus, so you can type something. Hey, this is my idea. So, and you can store it. Okay, so this is also anonymous. So thank you, Matthew. You just change it your name to the team number. Okay, so with this simple anonymous board, the passive students can make, yes, that's correct, can make their ideas and can publish their ideas in public. So it is very good tool for students to participate, because they have somewhat timid to show their faces, even show their names, even though it is not evaluated. So the freedom of anonymous environment can make them move. So it is very good for me to share this board with the students. So while the lecture is in proceed, so while this address is in proceed, you can type anything to publish your ideas in anonymously. Okay. And another one is that you know that currently I am focused and I'm sharing the screen. So enable screen sharing in your online conference tool. So focusing the video to the presenter. And this presentation is just a demonstration for them. And this is a screenshot of that presentation for some student. And this was tried by myself in the last semester. One tool is pair programming. Okay, so actually the programming education can be even more better in this environment. You can even transfer the control of the keyboard and mouse, and the students can control your environment. So they can solve the problems on your screen. So I just recorded them and make them public in my YouTube channel. So you just click this, then you can see a student is trying to solve that problem. Maybe, but this can be slow because I'm currently in proceed address the materials, and one of the student is challenging the problem, which was the midterm exam problem. So he's speaking the English, but so I just noted. I just make a note here for the subtitles for Korean students. So I can jump to some. So I'm sharing my screencast. So we are discussing on the problem, and then I can transfer the control and opening my folder, and he can play with this environment. And actually, he's just this is taken my control, but so I'm just creating a file, and then he can participate with typing some Python code directly inside of my Visual Studio Code. Okay, so he is currently solving the problem, and this kind of pair programming is that can be facilitated if you have some auto-judge program. So currently he's solving the problem here, but let me jump to somewhere. So I'd like to show them how to submit it. So in this part, I'm changing the code of students. So actually, he was using the if-else statement, but I'd like to just change it as a conditional expression in Python, just like in C. So, and then you can submit the material to here. So I'm selecting that file. And your auto-judge program is just determine the correctness of them automatically. So it is very good for students who is active to participate it. And some of the tools may provide you the quality check. So this kind of technique may be proceeded if you have some kind of tools. So sorry. So you didn't take a look of this kind of so okay. I just added. So can you see this screencast here of YouTube? Okay, so the quality check is performed here with some additional tools. So this tool is based on the SonarCube, and it was built on one of my students. But you can find the similar tools from the open source repository such as GitHub. So let me share this pair problem slide again. Okay, so using online judge can make it even better. And you know that there's online coding sites can be helpful if it matches to your lecture material, then you can use the top code or lead code as a supplementary material for programming education. And the final tool is gamification. So it is a simple tool to convert some quiz materials into a game. So if you have a simple set of questions and you can transfer it as a game. So Kahoot is a wonderful tool for gamification. And there's another tool named Socrative. So you can use any one of them. But if you'd like to enlarge them, so these tools provide some free account. But if you'd like to enlarge them, then you have to buy some of the plan. So let me just show you that I just make it public some of the problems. So let me just, so if you have some smart devices, please install Kahoot now. Then I can give you game pin. Sorry, it is. So I'd like to write down the game pin here in the chatting section. So once you install the Kahoot, you can type just the 7 numbers on the Kahoot. Then you can participate the game. So I'd like to watch one of you is just participating to the Kahoot. So if you open this, then there's a simple questions for ICCAI. So it seems slow. So it really? Okay. This is Kahoot here. So you can play it, you can start it. So you know the answer, it is not Korea, but Indonesia. So you can check it. Oh, that's right. And some of the ice is just taking, and the next is a professor, true or false. So otherwise is too fast for me to follow. So okay, so it is true. So in this way, the students is get rewarded with their points. Okay, so they have some fun with a simple quiz, and the quiz may be some of the important concepts on of your lecture material. So I didn't try the Socrative, but it is similar to Kahoot. So you can use these kind of tools to activate students anonymously. Okay, and you may get you may be informed that which part of your lecture materials is not fully explained, because from the feedback of the number of students of the game result. Okay. So, as a conclusion, so promote student activities. Teachers should do something more, and teachers should understand. Teachers and professors should understand the emotional barriers of students. So the passive students can be activated using questions, anonymous questions. So the methods for activate students is that screen sharing for presentation it is very normal, but if you are eager to communicate with one-to-one person, then you can solve some of the problems in pair programming, and that can be casted to in live casted to students. And the pair programming is facilitated with auto judge program. And I introduced a single tool of some of the gamification tools. So let's try them and share them with your students. Okay. Thank you for listening to my lecture. So do you have any questions?
Okay, thank you very much, Professor Gyun-woo. Let me introduce yours first. Dr. Gyun-woo is an associate professor at the School of Computer Science and Engineering at Busan National University in Busan, Republic of Korea. He received a bachelor, master, and PhD in computer science from KAIST, Korea Advanced Institute of Science and Technology. This is a very interesting presentation that proves that we can also have fun with online education. Yeah. Now I invite two questions from the audience since the time is very limited.
Yes.
Is there any question from the audience?
So Jos.
Okay. There is a question from Dr. Jos from Jos Dimanta Tarigan. Do you value student activity during the online class? For example, does it contribute to students' final score? And it is fair, considering some technical difficulty, for example, internet issues, may make the scoring system unfair.
Okay, so for the gamification, it is held on anonymously. So it is just for activating the students, but it is not attributed to the final score. But if you want to attribute it, I can do that with the pair programming. In that case, students can volunteer. I'd like to solve this problem, and in that environment, you can teach them one by one, and that effort is credited for the final score. Okay, but for other gamification tools, as mentioned by you, it can be unfair. Okay.
Maybe a follow-up question. Is it possible, Prof?
Mm-hmm.
Follow-up question. Do you think it's a good idea to put the student activity during online class as part of the final score, because probably it's a way to encourage them to actively contribute during the class? I mean, do you think it's a good idea, or without considering the technical difficulty?
Yes, but in that case, it should be performed with not anonymously. So as you know that the Zoom has a capability of survey. So this with the questionnaires in the survey, you can set it as anonymous or with names. So if you have changed it with names, then you can make it to the reflected to the real score. But it should be in in cautious manner, because some of the students, as I said before, they are hiding their faces, and some other guys may take the quiz instead of the student. So it may be in that case it may be uh, claimed by other students who do not think that it is not fair. Okay.
Okay, Prof. Thank you for your answer.
Okay, there's one question from the Q&A from Miss Diandra Hamawati. Kahoot is an interesting game education, and we can also make quiz there. Do you have any methods to teach lessons that contain a lot of mathematics equation or graph and essay quiz with interesting application?
It is not so possible yet because, as you know, it is just for promoting at the initial level. So it is adequate for just checking the concepts. Okay, so you are describing the concept of things, and then students can take some of them. So, but for mathematical questions, you have to build it with more fine-tuned document generation tools, but that may not be possible in Kahoot. So for myself, I didn't use the Kahoot as for mathematical questions.
Okay, Prof. Okay, just one last question because this seems very important. From Miss Ariana Unita, Professor Wu, what do you think the best way to evaluate student in the final exam during pandemic? As we know, it is hard to tackle the issue of cheating since the students can check the internet or WhatsApp the friends. Should we change the form or the final exams to all from the closed book to open book to open internet, something like that? Any
Uh,
idea?
yeah, so it is an important question. So if you don't like to open internet and open book, then you have to make the problem in a very cautious way. So for myself, for my cases for the past lectures, the fair manner of the evaluation is that the result is reflected by the participation. So if you participate in some of the reports and homeworks, and if you participate in the pair programming, so you have to get the credit for them. So the portion of the participation may be increased, and for the exam you have to design the problem in a cautious manner because it can be easily copied by other sources. Okay, so for my case, actually the implementation problem is not so good for the final exam because it should be held in a closed area. But if it is not possible to take an exam in a closed area and controlled area, then you have to make a problem such as designing problem. So there is no single solution. So, and you may change the constraint. You may change the constraint, and then designing should be performed by students to match the constraint. So that is a good style of for open book and open internet problems. But for if you have a controlled area, we can take the older style exam. Okay.
Okay, thank you very much, Professor Wu, for your interesting speak. I shall give the time back to the Master of Ceremony. Thank you.
Thank you.
Thank you, Professor Junbo and Mr. Andi for the second keynote speech sessions. And once again, thank you so much to Prof. Junbo for joining us as the keynote speaker for this occasion. Continuing with our next agenda is the third keynote speech sessions presented by the third keynote speaker, Professor Dr. Hendro Wicaksono from Jacob University Bremen, Germany. And it will be outlined by moderator, Mr. Jos Timanta Tarigan, SCOM MCOM. Without further ado, ladies and gentlemen, please welcome Mr. Jos Timanta.
Thank you for your participation in this session. We are now in the third part of our keynote speaker session. My name is Jostimanta Tarigan, and I will be your moderator throughout the session. Our third keynote speaker is Professor Hendro Wicaksono. Welcome, Professor. Thank you for your availability to participate in this conference. And allow me to introduce you to our viewers. I'm sorry, I haven't seen Professor. Okay, yeah, okay. Allow me to introduce you our viewers. Professor Hendro is an Indonesian who has lots of achievement internationally. Actually, some of us already know news about Professor, as there are many news coverage in national news media regarding his achievement. He is a professor of industrial engineering in Jacobs University Bremen, and currently he is assigned as the head of intelligent data management for Industry 4.0. He received his master degree in information and communication engineering from Universitat Karlsruhe and his PhD in IT for mechanical engineering in Karlsruhe Institute of Technology. His research interest is in data management, applied machine learning, Industry 4.0, and impact assessment, among others. In this session, he will present one of his recent work titled Achieving Sustainable Development Goals in Industry 4.0, Context through Collaborative Innovation. Before we begin the presentation, I would like to remind the audience that there will be a question and answer session after the presentation, but feel free to write your question in the chat room during the presentation. I will sort and listen out to be answered later. So without further ado, please welcome our third keynote speaker, Professor Hendro Wicaksono. The audience is yours, Professor.
Okay, thank you. I will try to share my screen. Can you see my screen right now?
Yes, sir. We can see your screen.
Okay. Very good morning, everyone. Thank you for the organizer that invite me as a invited speaker in this conference. Thank you also for attending my session today. So today I would like to summarize some of my research in Germany. So it's actually consists of several research that I put it together as a title that match today's or this conference topic, which is about digital transformation for societal well-being in a sustainable environment. So because of my research focus or methods based on the data management and the context is in the Industry 4.0, I will like to relate this title to my research. So today's talk, I would like to divide it into 5 parts. I would like to introduce my group first and my university, and then about Industry 4.0, which is coined in Germany, and how the Industry 4.0 could, or the context of Industry 4.0 could achieve the global sustainable development goals set by the United Nations, and then what is the collaborative innovation model and how it could be implemented. And at the end, I would like to give you some examples of research where I involved that's actually addressing the global sustainable development goals. In the same time, it used Industry 4.0 technologies. So Jacobs University is a small university in the city of Bremen in northern Germany here. So we are focusing on internationality, interdisciplinary, and research and innovation. So we have around 1,600 students, and what is quite unique is that our students come from more than 120 countries. So the university is quite international. It's like a miniature of the world in a small university. And also we have quite a high number of professors and researchers. And even ranking is not our main goals, but it's kind of indicators that we are quite successful to focus on the internationality and the research. So the internationality is reflected in our research group. So it's my team between 2008 and 2020, consists of PhDs, masters, and bachelor students. So the methods or tools that is the fundamental of our research are around data management, from data integration using linked data, and statistical analytics and machine learning to analyze the data. And then we also focus on knowledge graph to extract the semantics from the data, and also to extract the correlations and represent it into so-called ontologies. And we also text or annotate geometrical data and geodata for visualization with semantics. And of course, because we are part of industrial engineering departments, so most of these method and tools are applied to these four main area of application: smart cities, supply chain, construction, and agriculture. So innovation, technologies, and knowledge management are also focus of our research, because the idea is how to apply those technologies and exploit those technologies for in industry 4.0 context as product or services. So you can see here is the main core methodology that's have been proven in these different research projects funded by different agencies, from German government to European Union government. So we collect the data from different sources, from sensors, from open data, and also from simulation data. And then we integrate it using linked data. Before that, we need to do data uplifting or semantic mapping. And then we extract the correlations and semantics using machine learning. And the results are stored in W3C standard on representations called ontology, and it resulted in knowledge graph. And from this knowledge graph, different kind of application can run. For example, simulations, optimization. We focus on the hyperheuristic optimizations, and also how we can enrich the geometrical data through semantics. So what is, first of all, I would like to introduce the Industry 4.0, because there are different interpretations of the concept of Industry 4.0. So what I'm developing the definitions and the concept of Industry 4.0 together with my colleague here, is that the Industry 4.0 focus on the digital transformations, which consist of digitalization, interconnections in form of digitalization, interconnection, and intelligence in form of Internet of Things, services, and people. So that means we don't only connect the things, the physical things, but also the people, and also the services or the businesses. So the development, if we talk about industrial revolution, it's not only about technologies. It's about also the transformation in society and also economy. So the focus of the transformation in Industry 4.0 is to achieve global and smart production. So that means we will be able to provide services and also products independent of time and space. And smart means here to have a minimum intervention of human in the production process. So this production is in the sense of, in a broad sense, from product design, production, and then also distribution and consumption. So what are technologies that that enable this Industry 4.0? I divided into three layers of technologies. So the infrastructure, which related to how the basic infrastructure and how we can collect the data and store the data. So this includes Internet of Things and cloud computing to collect and also to store the data and link data to interlink them. And then intelligence layer deals with the extracting values from the data. So it includes big data analytics and artificial intelligence. And the top layer is about the interaction of human with the data. So it includes augmented reality, virtual reality, and mixed reality. That obviously is about interaction with and also with information. And advanced robotics here included here. So the definition of advanced robotic here is the robotics that can collaborate with human, not the ones which substitute the human roles in the industry, but the one who can interact and collaborate with the human. And also 3D printing, because of it's what you see is what you get, so we can get a physical product directly from the virtual representation. So if we talk about an end-to-end solution of Industry 4.0, so there are 4 pillars that should be, one of them should be implemented in the solution. So the first pillar, or these 4 pillars, called smart PPR plus data-driven business. So the first pillar is this first P, or smart product. So it means that it's a product that can give information about itself, and it has some kind of automation degree, so that it allows minimum intervention to human. So usually it's product that equipped with some sensors. And the second P, smart process or operation, these are processes in companies and process that interlink different organizations. For example, supplying process, deliveries, distributions, and production processes. So it's connected and has also some degree of automations. And smart resource, or the R here. So it means the the facilities, the infrastructures like buildings, machines, and also vehicles that help the production processes, but not part of the value adding itself, like product. So it smart here means that the buildings, vehicles, and also the industrial machines that can give information about itself and allow minimum human intervention. So as a consequence of this smart PPR, we will get huge amount of data. So that's why one of the pillars in Industry 4.0 is to be able to extract values from data, so and then offer this value as a service or as a business. So it's called data-driven service. So this gives you some example of how the industries are transforming into data-driven service, or at least including the data-driven service in their product and service. For example, Rolls-Royce, they manufacture these airplane engines. Now they don't only sell the manufacturing engines, they also provide a service like real-time monitoring, predictive maintenance, and optimizations to airlines that use their engines. So it's kind of paid service. So this service is based on the data that are collected from sensors installed on their engines. In different sector is also the same, like John Deere, they install sensors on the machines here, farming machines, and then provide service based on the data collected from the sensors. For example, the service are monitoring and social media that connect the different farmers. And also we can, in the fashion industry is also the same. So like Ralph Lauren here has some product shirt, sports shirt that equipped with sensors, and also provide monitoring and early warning systems to the customer. So this is kind of the typical business model, so to say. So to enable the physical product, which usually can be accessed locally, to be accessed globally, so as digital service, or adding digital service on it. So what are some implications of Industry 4.0 is some jobs will not exist anymore, or it will be substituted by the technologies. So you can see here on the right hand side are the the jobs that most likely will be substituted by the technologies, like here dealing with the transportation, material moving, the productions, and also simple office and administrative support, and so on. And on the left hand side here are the jobs that's less likely to be substituted by the technologies. Here, for example, the computers, like programmings and so on, educations, healthcare, and also management. Even like the profession like doctors, medical doctors, and also a lawyer can be substituted by artificial intelligence. So here some countries and how many percent of the employment has a high risk of computerizations. So this computerization can substitute the workforce there. And where is Indonesia right now? So according to the data, is in Indonesia, 56% of the job is at the risk of automation, according to ILO. So that means here is around, Indonesia is around here. So 55% or 56% is not as crucial, like in Ethiopia or Nepal, like this. That is predicted 85% to or 80 to 85% of the employment will be at the high risk of computerization, according to ILO. So these 4 pillars of Industry 4.0 that I mentioned before can be applied in different sectors. So that's the words 4.0 come from, like agriculture 4.0 and so on. So in the manufacturing, for example, is quite typical. So so this is like the origin of these 4 pillars, and then it can be transmitted. This concept can be transformed into like agriculture. So where the product of agriculture is the plant itself or the commodity itself, and the smart operation is the connected farmers, and also the connections between farmers to the suppliers and also to the market. And the smart infrastructure here is like the automatic watering, smart transport, warehousing that equipped with the sensors, like cold transport, cold logistics. And here, of course, because they produce data-driven service in agriculture, like the one is provided by John Deere. So from this concept, we can derive into different sectors. So health, for example, the product is itself the human health. The energy, the product itself is energy that or power that can be measured using smart meter or power meter. And health, of course, we can measure or we can collect the data about health from smartwatch, for example. So, and what are the roles of the Industry 4.0 technologies in achieving global sustainable development goals? So, what is the global sustainable development goals? This is like 17 goals set by the United Nations. It's about the goals for integrated approach for a better future in 2030. It's through the balance between social, economic, and environmental sustainability. So these 17 goals can be clustered into goals that focus on the environment, focus on the socials and economy. But they are interconnected. So that means we cannot only consider only one goals and ignore the other goals. We need to consider them as an integrated and interlinked goals. One of the applications of achieving these sustainable development goals is through the Energy 4.0, where we can apply these different technologies that I mentioned before, like IoT, and artificial intelligence, to achieve at least these 3 main goals: affordable and clean energy, industry, innovation and infrastructure, which is here the smart grid infrastructure, and climate actions. So in this virtual power plant, in the context of smart city, I also involved in these projects so that we integrate the use of renewable energies into the energy system of a city. So as the consequence, because the availability of the renewable energy is intermittent, so that depends strongly on the weather. We cannot set how much energy we can provide to the city, for example, at the beginning. So that we need some kind of artificial intelligence to forecast how many energy that will be generated within the city and how much energy will be consumed by the people within the city. So that means we need both some kind of forecasting on the production side and the consumption side. So in the agriculture and aquaculture sector, which is usually like the economic backbone in developing countries, so this approach can be also applied. So the SDG that would be achieved here is zero hunger, climate actions, and life below water. Keep the life of the fishes and the corals and so on, and life on land. So that means here we can optimize the use of the land, the use of the resources in aquaculture through technologies. For example, by optimizing the time, the commodity, and also the amount of water, the amount of, for example, fertilizer, we can keep we can protect the environment here, and we still, by still using the same amount of land. So we can increase the productivity of agriculture and aquaculture without expanding the area for farming, for example. So for this achieving SDG and in the context of Industry 4.0, what should be implemented in Indonesia? So I have here some thoughts. So what kind of sector, in which sector it should be implemented in Indonesia? So the consideration are these 5. So first is to give wider impacts, especially people living in villages. And second is to optimize the value and the efficiency of key natural resources of Indonesia, which are biodiversity, for examples. And the third is focusing on the developing of human skills, not using or exploit the human strength. So that means we need to focus also on the educations and the jobs that you can see in the previous slide on the left hand side, and to optimize the roles of all of societal elements. In these cases, the people living in the rural areas, the startup, the SMEs, the government, and the academia. And also what is important is to bring Indonesia as a leader, not just a follower. So what are the focus sectors? So what I'm thinking are these 5 sectors: agriculture, aquaculture, the mining, the renewable energy, and healthcare. So how we can achieve those SDG in the Industry 4.0 context? So the key is innovation. So the innovation can be achieved in more fast manner by using collaboration. So the triple helix innovation model is the innovation to accelerate the model to accelerate the innovation on the national level or on the country level. But there are different kind of triple helix. We will see which model is the best for innovation. So the first model of triple helix innovation is this. You can see like this. Triple helix is about the roles of government, university, and industry in the innovation. So in model 1, government has the authority over university and industry. So usually it's in the developing countries or in the countries which has some kind of authoritarian kind of government. And in the model number two is there's some, government, university, and industry, they are on the same position, on the same level. So there's some interaction between them like this. I think Indonesia is now in this model two, have this model number two. But the most ideal is actually the number three. So they have the same position at the same level. Yeah, government, university, and industry has some kind of roles in the innovation. But here they move closer comparing to the model two and creating an environment, integrated innovation environment. So how we can implement this? So we can talk, I will show the slide later. So typically innovation is close like this. So usually in the pharmaceutical companies, the innovation is close. So it takes around 15 years, for example, to create a drug. So perhaps between 5 to 15 years. From 5,000 trial, it can be like only one successful product. So this innovation is done only by one organization or one company. And open innovation is that to open the funnel, so it allows different organizations to contribute to the innovation. For example, including the universities, including the government, and they can enter on the different phases of innovation. So the implementation of triple helix, the model number three here in Germany. So there are 4 here to create the environment for spin-off in the universities. So by involving government and also industry, and to have open research and innovation collaborative projects. So we will focus on this implementation today, and also other implementations, for example, strategic alliances and regional clusters of innovations, and also collaborative innovation labs. So, but because of the time, I only focus on the open research and innovation projects. So how it works? So this many times I have been involved in this open research in innovation projects where the government give funding for a collaboration that aim for technological innovation. So the collaboration should consist of at least universities and SMEs. Yeah. So it can be also consist of university SMEs, large enterprises, and applied research organization like Fraunhofer. Here, because the innovation project, research innovation project is quite a high risk, because the possibility to not to result in innovation is quite high. So then the government gives subsidy to the SMEs and enterprise who are involved in this kind of collaboration. So that means the SME will get like 50 to 60% of reimbursement of their costs in participating in research and innovation projects with universities or applied research projects, applied research organization. And large enterprises also get smaller amount of subsidies. So why subsidy, not grant, not like 100% grant? Because the government need to see that these SMEs and large enterprises has some kind of willingness to contribute with their own funding for innovation or to innovation. So these examples of projects of collaborative innovation that involves SMEs, large enterprises, and universities and research organization, like this project called Delphin. So I'm involved here with some other universities, and SWT is kind of utility companies owned by the city of Trier, and also some smaller enterprises like pharmacies and so on. And also on the European level, we also do the same here. So this is, for example, the project in smart city. So how this triple helix model can be related to the sustainability? So that means this focus on Indonesia, for example. This is Indonesia, where the biodiversity and natural resource protection is kind of impulse also to do some kind of new innovation, but at the same time it's a constraint for us to have the innovation. We are not allowed to have innovation that can destroy the environment or biodiversity, but we can consider this constraint as also opportunity to have innovation. And also the resource or the opportunity that's owned by Indonesia that is quite unique for Indonesia is gotong royong or collective society. So this is as example that, or we need to exploit this collective society for innovation, not only just to solve problems or to help people in difficulties like in natural disasters. So currently we focus only on the helping people, but right now we will need to exploit it towards innovations, collaboration for innovations. These are some examples of collaborative research projects that related to IT and also to achieve some aspect of SDG. So the first one is the project called EcoBalance. Here's about using IoT and cloud architecture to improve the energy efficiencies in the so-called manufacturing companies. So we need to avoid the excess of energy, uses of energy. We need to avoid peak loads. So we install sensors, and here we use Raspberry Pi, and we collect the data and then do this machine learning to extract or identify the energy consumption profile for each industrial machines. For that, if we can identify the consumption profile, we can do forecast of power consumptions and also cost of the whole process that produce customized products. And then we also doing some optimization of production planning and control, and also optimization of production schedule by considering different constraints and objectives, like for example power peak avoidance, having whether the objective is having lowest cost of just avoiding the power peak, and whether or on time lead time. So we applied this research result in some metal processing companies. The second is on the European Union level. It's about integrated smart energy systems using knowledge graph and machine learning. The idea is to have some kind of district or region or city that integrate local and renewable energy sources, and at the same time to achieve lowest energy consumption within the district. So we collect data from different sources. So from open data like weather, for example, and metering data that we install sensors on some buildings, some main buildings, and we simulate the energy demand using tools for energy simulation like Energy Plus, for example, and then from there we can get data, and from the integration of those data into knowledge graph, we can get correlation of the, for example, consumption and whether the activities, the infrastructure conditions, and so on. We do forecasting of power generation and consumptions on the city, in the city, and then do the energy simulation to estimate the energy and heating demand for some building which don't have any installed sensor. Based on the building properties, we can estimate the consumption and heating demand. And we also develop some kind of optimization method to find the optimal renewable energy infrastructure planning. Here, for example, which location we can install wind turbine, in which location we can install like solar cell. We apply this method in 3 cities: Lisanello in Italy, Sevilla in Spain, and Cambridge in UK. Sorry, I have to turn off. Okay. And the methodology that we combined these 3 data sources, or 3 types of data sources: reference data, this is from open data or public data, metering data, or it's from the sensors, and simulation data from tools like Energy Plus. And then we related them, or we interlink them using linked data or knowledge graph, and then the application run using machine learning. This is quite similar project, but the focus here is to optimize the use of renewable energy sources in the production. So we also use a knowledge graph as a semantic middleware that interlinked sources. So using this kind of semantic middleware, we don't have to have some kind of centralized data stores. So the data can be retrieved on premise depending on the application who need it. So we can just keep the data source storage in the original location. So also we have also some initiative to transform the research results that, for example, from the project DERIT that we discussed about the smart cities or smart energy systems, and of course to do the technology transfer, we also need some steps, not only research, we need some steps like the integrations of these different project results, for example, and demonstrations, and of course market and cultural response analysis for Indonesia, and also how we can connect Europe and Indonesia in terms of business, long-term business. So we need to create some kind of business model that can both useful for Europe and Indonesia. And for this initiative, we collaborate with 2 universities and also 2 companies. And we applied this method only in some building complex, like here in the museum in Jakarta, and this is Taman Mini actually, and some exhibitions areas and office in a campus, and also dormitory in a campus. So as a conclusion, smart PPR, or product, process, and resource, and data-driven business are pillars in the Industry 4.0 ecosystem. So this is kind of end-to-end process in Industry 4.0. And triple helix model 3 is required to accelerate innovation, at least on the national level. And we need to go forward open innovation instead of closed innovation, because we can achieve, or it's more effective, and we can achieve in a shorter time. And of course, from these projects that we talk about, because by including industry, universities, and SMEs from different background and different sector. For example, for the smart city solution, we collaborate with electronics company who provide sensors. We collaborate with IT companies. We collaborate with municipalities. We collaborate with energy consultants. So this kind of interdisciplinary collaboration will enable or facilitate the innovations. Without this interdisciplinary, so we don't have these multiple perspective in viewing problems or issues, so we cannot achieve an effective innovation. And these sustainability development goals are both impulse and constraint to do innovation. So because we can create innovation that directly address those sustainabilities, so it's kind of opportunities, but also if we develop innovation, we need to consider them as a constraint. We need to still consider the climate protection, for example, and society. So thank you for the attention. So if you have questions later, so in this session you can ask, but if you have question later, you can send me an email here. Thank you.
Correctly, so you just presented. So the idea is you just presented as a strategy in as a part of modern innovation 4.0 context. And I have one question from Erna Burdiati. The question is, where is the position of community in the Sustainable Development Goals model? As we know, community involvement is important in providing the solution, or maybe make it as a model of quadruple helix.
Yeah. So in this triple helix, actually the one or the main actors that can play the major roles in the innovation. The society is something that should be addressed in the innovation, but they don't have to be actively involved in the innovation. So because innovation is about something that has some kind of commercial exploitation. So that means if we only have some ideas and plus some tangible products or service, so it's called invention. But if we have and the output of invention is just patents, for example, and if we add activities for the commercial exploitation, is called innovation. So of course, to make the innovations more sustainable, so that means sustainable means so another innovations can be created continuously. You need some kind of financial independency. So that's why here this industry means something that will get profits, and the society is more like the impact society and also environment. Here it's more you see here actually the both, and environment here is something that is around this triple helix that should be addressed as an impact, but it's not really the major roles. Yeah. So this concept, according to this guy Karayanis, is also quint helix. So, but these two others, like environment and civil society or the community, are the impact they're targeted by innovations. It's not the main actors in the innovation.
Thank you, but sorry, can I add my question?
Yeah.
That the society, the problem is actually come from the society. Is that correct?
Yes.
Yes. So why it's not the main actor of this triple helix?
Yeah. So that means the innovation should
yes.
Yeah, the innovation should address both the society and environment.
Yeah.
So this is like the impulse or the problems are also the driver of innovations, but in the process of innovation itself, in the process of innovation, you need to have research, you need to have technology development, you need to have commercial exploitation, you need to have marketing, you need to have the production. So this in this innovation funnel, what I'm talking about innovation is this innovation funnel. So the society is not really part of the main actors, the actors in this funnel. Yeah. So they just something that need to be considered when we doing this innovation or developing the innovation.
Okay.
So the main actor is only the three, yeah. Government, industry, and the university, academia, I think, yeah.
So yeah, that's just actually the model that's developed by these two guys here, but it's then applied also in Germany. So where they have this so the same or equals level in the terms of innovation.
Okay. Even though the problem is come from the society, yeah.
Yes.
But okay. Thank you for the answer.
So it's I think
okay.
It's a must. I mean, it's a must to have. To address the problem in the society. It's not just addressing the problem in government, faced by the government or industry, but yes, I think it's a must to consider both society and environment.
Okay, thank you.
Okay, thank you for. Uh, well, I requires lots of activity of your model, or do you have any modification in the research during this?
I'm sorry, I think the connection is not really good. Could you repeat again? So your voice is discontinued. Yeah.
Do you think there's an effect of research in the current pandemic corona condition?
I'm not sure. I'm sorry because it's disconnected. I cannot get your. I'm not sure whether it's the problem. Maybe it's in my side because it's quite early morning in Germany. So usually the maintenance of internet provider happen in the early morning.
Hear me, Prof? Here.
It's keeping disconnecting. I mean, discontinuous. I mean, your voice is discontinuous, so that I cannot fully understand the whole sentence.
Sorry, Prof. Can you hear me now?
Yes, it's better.
Okay, I'm sorry. So my question is that your triple helix innovation model requires massive communication between all the contributing parties. Do you think that the current pandemic condition affect the quality of the research, considering it's almost impossible for us to perform a face-to-face communication?
Yes, it affects a little bit, but it's I think it's not the problem in face-to-face communication or not, but some of research fields or innovation fields required physical presence. So it's not about the coordinations that is the problem, but more like some of activities in the research that conducted in the research required physical presence. For example, um, if you're required to observe some kind of um, city, transportation in the city, for example, because then it's not perhaps first the object is different, so that means perhaps the research that we aim before is not really the case anymore because of, like, in the smart context of smart city, smart transportation, the amount of people who use the transportation is very, very low, and you cannot do some kind of transportation planning and so on, or capacity planning, innovation towards the capacity planning, for example, of transportation. But like the meetings and coordination between parties is not the problem actually, because still using tools like Microsoft Teams or Zooms, we still can communicate with people from different organizations. So according to the survey in Germany, also for the people who works in research, I mean research and especially research in IT, this situation in pandemic increase their productivities because they can just jump from one meeting to another without moving physically, so it's more saving the time. Yeah, but in some field research is quite not possible to do the field research, so that's actually the problem to do the field kind of research.
Um, okay, maybe a follow-up question. What about gathering feedbacks from your end user of your research product? Is there a problem in that too?
Again, the problem is not like contacting the people and get the feedback from them, not like that, but for example, to install the sensors, uh, uh, some of our projects is delayed because we're not allowed to visit the company and install the sensor because of the rules. But I mean, to communicate with the end user is not the problem. The problem is just these physical distancing rules that doesn't us to allow that doesn't allow us to be to presence to be there and install the sensor, and also to do some physical activities that required the presence there. Again, it's not the interaction with the end user, but it's more like the activities.
Okay, thank you, Professor. I think we don't have any more question, and if the audience have more question, they can pass it to us, and we will pass it to Professor Hendro. Thank you for your answers, Professor. And I think it's better if best we can now end this third session. On behalf of the community of ICCAI 2020 and the audience, I would like to thank you for your participation in this conference. I'm sure that your presentation is valuable knowledge for us, and we wish you all the best in your future endeavor. And we hope that in the future we can collaborate more, hopefully in the research part of our work. I would like to appreciate all our audience in your participation. I hope you enjoy the keynote sessions in this conference, and thank you.
Thank you so much. Once again, thank you so much to Professor Hendro and Mr. Josimata for the last keynote speech sessions in this conference. And once again, thank you so much to Prof. Hendro for joining us as the keynote speaker. Now, ladies and gentlemen, we are going to do a photo session. So please kindly to turn your camera on so we could take the pictures together. Thank you. Okay, I will count into 3. 1, 2, 3. Okay, thank you so much. Ladies and gentlemen, we have now reached the end of the keynote speech sessions in ICCAI 2020. But before I close this keynote speech sessions, I would like to remind you that regarding our schedules, after this, we are going to have a lunch break until 1:15, and then we will continue our conference with the parallel sessions at the time. So for presenting authors, please be on time, and be ready based on your schedule at that time. Excellencies, distinguished guests, respected participants, ladies and gentlemen, we have now come to the end of the keynote speech sessions in the 5th International Conference on Computing and Applied Informatics 2020. On behalf of the organizing committee, we would like to express our utmost gratitude to all distinguished guests and participants for joining us in these occasions. And we are very sorry for any inconvenience or shortcomings. Thank you so much. The last I say, wabillahi taufiq walhidayah. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam
Waalaikumsalam
warahmatullahi
warahmatullahi
wabarakatuh.
wabarakatuh.
Ladies and gentlemen, as reminder once again, the parallel sessions will be starting at 1:15, and then you can see the link for the Zoom meeting room at the chat column. So please be ready at that time. Thank you so much. Please enjoy your lunch, and have a good day.
bisa lab. Udah ya. Kayak Maya fotonya aja itu.
Ada lah Bang.
Adanya.
Apa kok di foto tadi? Abang yang nggak nampak.
Iya, nggak dibilang si Ade. Aduh.
Kita live ini.
Kayaknya. Aku live ya, mau makan siang.
Oke, selamat makan siang.